and screen. Okay. So, oops. What happened? Okay. 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 Yeah. So that was it. Okay. Yeah. Okay. Good. So then, let me bring up the camera. Maybe it takes a minute to get. Okay, and so we'll just go through this. It's yeah, we're just about done anyway. But I just want to go through this a couple of times. And this is the skill that I really want you to take away from this chapter more than anything else. Okay, let's see. Why did that not come up? Let's try it one more time. Oh, there we go. Okay. Okay. All right. So, okay, good. All right, so let's say we have a truth table. Let's say we have three inputs, A, B, C, and we have an output F. Okay, and we'll just say, we'll group it in rows, group the rows in pairs, just to make it easier to follow. So 0, 1, 1, 1, 0, 0, 0, 1, something like that. Okay, so how do we how do we take this and represent it with a set of input AND gates and an output OR gate? Something that would look like this. Since there's three variables, we might have as many as 3 inputs to each of these gates. We might not, but we might. And then one output OR gate. So we can represent these with the little dot. We can put a plus here just to make it easier. And this is our F coming out. And this is our ABC going in various ways to these inputs, including A prime and A, B prime and B, C prime and C in various arrangements. All right, so how do we get from this to this? So what we do is we do two things. One, we do what's called, we implement it with either, we use either what are called the min terms or the max terms. And I usually capitalize the M in max. And I usually don't capitalize it in min. The min terms are based on where F equals 1.
Can you scroll down?
Yeah. So the min terms are based on where F equals 1. And the max terms are based on where F equals 0. And it all sort of works out because we use AND gates for these terms and we use OR gates for these terms, it sort of works out. So where none of the OR gates generate a 1, that would be a max term, and where the AND gates generate 1s is what it defines the min terms. And so how do we do that? Well, it's really pretty simple. So if we take this truth table And let's say we'll do the min terms to start with. Now the min terms are, we just look at these and we can kind of write it. So the min term for this row, so if we do the min terms here, we'll extend this. And then we'll do the max terms in a minute. So the min term for this first row would be, because A is 0, B is 0, C is 0, we would represent this A prime, B prime, C prime. And the max term is just the opposite. We call this, the max term would be A plus B plus C. Now it turns out if you invert this, you actually do get this. But the min term solution and the max term solution are never, never, never inverses of each other. They look like they might be, but they're not. The terms, the individual terms are the inverse, but the solutions are not. They are equal to each other. The min term solution and the max term solution are always equal. And that's because we would never include a min term and the max term in their solutions from the same row, because we only use the min term if F is 1. So in this case, we wouldn't use this min term. We'd use the max term because that F is 0 there. So if we're going to do a max term solution, we would just use the max terms. And if we're going to do a min term solution, we'd use the min terms from these rows where F is 1. So the min term for here would be A prime, B prime, C. And the max term would be A plus B plus C prime. And here the min term would be A prime, B, C prime. And here the max term would be A plus B prime plus C. And here would be A prime, B, C. And here would be A plus B prime, C prime, and so forth. So you can see this, these terms are always the opposite of each other, but the solutions are always equal because we never use, we'd only pick, if we're picking the max terms, we're going to pick the ones from this row, this row, this row, and this row. If we're doing the min terms, we pick it from these rows. So we'd never use the same term for both terms from the same row, the min and the max from the same row. That would never happen. Okay, so let's take this again. And you stick with this truth table, and I'm going to write the min term solution for this truth table. All right. Now, one thing that I always sort of have to back up and talk about that confuses students a lot: where do we get the F? Somebody tell me where the F comes from.
The customer, or whatever who's describing what they want as the outputs. That's
right. It comes from the customer, or as I like to say, it comes from God. You sort of have to make your customer God because they're paying the bills. All right. So, okay. Exactly right. Very good. All right. So let's do the min term. Let's write the min term solution. So I just made this F up just out of thin air. So this doesn't have any particular meaning. So let's do it. So the first min term. So, and I normally, we also have a shorthand notation for the min term and the max term. We can number every row. Remember, we always start with 0. So this is row 0. This is row 1, 2, 3, 4, oops, 5, 6, and 7. We always start with 0, so we don't have an 8 down here. It's a 7. So the min terms I need then, I need the min term from row 1, 3, I'm sorry, 1, 2, 3. I don't need the min term from row 0. I don't need it from 4 or 5 or 6, but I do need 7. And so I write this F equals the sum of the min terms, the sum of the min terms, obviously in this case, we sum from 0 to 7, but we only want min term 1, 2, 3, and 7. So we don't write these in. So those are the min terms we want: 1, 2, 3, and 7. And if I want to write the max term, I write F equals the product, which means the ORing, and this means the anding. No, that's wrong. I'm sorry. This symbol represents the output gate, which in this case is an OR gate. But these are AND terms. Whereas here, the output gate is an AND gate because we're multiplying, and here we're summing. All right. And in the case of the min terms, we use a capital M. Use a capital M, and we write them. In this case, we would have min term. So we have min term 0, 4, 5, and 6. So it would be capital M 0, 4, 5, and 6. So that would be that's the max term shorthand. That's the min term. That's the max term shorthand notation. This is the min term shorthand notation. And when I ask you to give it to me, to give an answer, sometimes I'll ask you to give it in notation. And when I want it in notation, that's how I want it. I want it, say if I want the min term notation, I would say F equals the sum of the little m, whatever. And if I want it in max term, F is going to equal the product, which again, this is an output OR gate. That's the output AND gate of the capital M's. These are OR terms. These are AND terms of some number. Okay. All right. So in our case, we're going to do this is our shorthand notation. That's a little messed up. But how would we actually write? So that's the notation. But how would we write the expansion, where we actually have the logic expression written out? Well, let me do that. So here's our truth table again. So I'm going to take the min term from the first row, which in this case is, because these are all zeros, that first min term is going to be A prime, B prime, C prime. So F is going to equal this, plus I'll take the next, the first row is the output 0, so I don't take that min term. The min term I want is row 1. That's A prime, B prime, C. So we have to get rid of this. So let me just start over. On this side. So I take the row 1, not row 0, and this is going to be F equals A prime, B prime, C, plus this row where F is also a 1, A prime, B, because that's a 1, C prime. So A prime, B, C prime, plus this row, A prime, B, C, and then not this row because F's a 0, not that row, F's a 0, not that row, and finally this row where they're all 1s, so that's going to be plus A, B, C. All right, so that's now my expression for F. F equals A prime, B prime, C plus A prime, B, C prime plus A prime, B, C plus A, B, C. Now I can use some of the rules of switching algebra to simplify this, and I'll show you how to do that when we cover chapter 4. But for now, I'm just going to leave it in this form. So that is my solution. Now, what would that look like? Well, it's 1. This is an AND gate. That's an AND gate. That's an AND gate. And that's an AND gate. In this case, all these AND gates are going to have 3 inputs. And so I would have an AND gate here, an AND gate here, an AND gate here, and an AND gate here. And this AND gate would have this in, so that would be A prime, B prime, C. Or if you wanted to draw in bubbles or inverters, you could do that. So this would be, you could do this is A prime, so I can do an inverter here and put that in. But we normally don't do that. We normally just write A prime. Makes it a lot easier. B, C prime. And then this is A prime, B, C. And this is just A, B, C. And all these then go into one output OR gate, and that's F. So that's this logic diagram implements this logic expression. And that's how I do it. And with the max terms, it's exactly the same, only with the max terms, I'm going to use OR gates as the input gates with one output AND gate, and I'm going to use the zeros. So here, and I have to flip these. That's maybe the weird thing. So this one would be F equals, so this would be A plus B plus C, because it's an OR gate, times this one here. So there's a 0. So that's A prime plus B plus C times this one, A prime B C prime times this one, which is A prime plus B prime plus C. So we have 1, 2, 3, 4. In this particular case, because there are 4 rows where F is 1 and there are 8 rows, there's 4 rows where F is 0. Doesn't necessarily have to work out that way. We could have 2 rows where F equaled 1 and 6 rows where F equaled 0, or we could have 1 row where F equaled 1 and 7 rows where F equaled 0, or vice versa, or whatever combination the problem actually gives us, because this just comes straight from our customer for whatever particular application they're interested in having. So this is our given, and this is how we can implement it in a 2-layer network with a set of input OR gates and one output AND gate. So our F comes out here, and we put A, B, C in here. We put A prime, B, C in there. We put A prime, B, C prime here, and we put A prime, B prime, C in there. So that's the 2 different ways that this truth table can be implemented. One way in an SOP form. So here's our SOP form. And one way in a POS form. And here's our POS form. Now this whole designation, POS and SOP, is so confusing. And the reason it's confusing is because the P stands for a product, and that refers to the output gate. And the sum refers to these OR gates. Remember, you could represent those with a little sum sign and that with a product sign. Whereas in the SOP, the sum refers to the output gate, and the products again also refer to the 3 input gates that are ANDs. So sum of product terms. So we're ORing AND terms. Whereas in this other one, we are ANDing of sum terms or terms. Input OR gates, output AND gate, input AND gates, output OR gate. Okay, so that's what I want you to get. I'm gonna stop sharing that. Let me give you a chance to ask questions, and then we'll quit.
So, sir, your minimum terms will always provide a OR gate at the end, while your maximum terms will always provide a AND gate at the end?
That's right. Yeah, because the product of sums means you're going to multiply all the OR terms together, and the sum of products means you're going to sum all the and terms up with an OR gate. Again, whoever picked this nomenclature must have hated students, because it is confusing. And it's really sad how confusing it is. Because we're taking these words from algebra, which don't mean what they say they mean. They don't mean what they mean in algebra, because we're not multiplying things together, and we're not adding things. We're ORing and ANDing. But they just use that nomenclature, and then they put the sum, the final gate is first, and they put the input gates last in the SOP and POS designations. But SOP and POS are universally used, and so you kind of have to get used to it. But it's a miscarriage of justice for sure. What are the questions? So hopefully, I'm going to send the TA an email. I'm going to start my office hours right now. In 2 seconds, I'm going to close this Zoom and start that. And I'm going to see if I can get in touch with my TA, and hopefully we'll get the TA to conduct classes this week. All right, we will talk with you later then, unless somebody else has a question. All right, everybody have a good day. Sorry for the disruption. That was a strange, just power went out. All right, talk to you later.